Okay, folks, looks like we're right at 7 now, so we might as well get started. And if anyone else joins, they can always catch up as we go. So I have to ask a couple of questions before I start tonight's session. And the first question is, how many people are very familiar with PixInsight and its terminology?
So
So you're familiar enough.
I'm familiar now.
Okay. So bear with me. I'm going to turn my video off just to save bandwidth here. And I will share my screen. So just bear with me. Come on, mouse. Okay. And now I should. So the two. Okay. I have to move a few things around here. Bear with me.
Mhm.
There we are. That's better. So I think it's better. There we are. So what we're looking at here. Okay, I got one more thing to move. Bear with me, folks. There, now it's at least out of the way. So what we're going to go over tonight is basic image stretching in PixInsight. And the reason I asked if people were familiar with some of the terminology used in PixInsight makes a distinction, properly so, between images that have been stretched and images that have not yet been stretched. Let me rephrase that. Not yet been non-linearly stretched. Basically, when you get an image and you calibrate it and you noise reduce it and sharpen it, not in that order, and color calibrate it, that's sort of the extent of what we'll call the linear processing, unless you want to separate stars out, of course. And what that means is you have not yet applied a non-linear stretch to the image. Now, just to give you an idea of what I mean, I'm going to pull up a curves transform. I can pick an image here. I can stretch this image linearly. And to do that, if I can get PixInsight's curve tool to cooperate here, bear with me. It doesn't always like to do this, so. And tonight is no exception. Okay, I can make it dimmer. There we go. One sec. Get rid of this point. Come on. There. So I'm going to dim an image linearly. And if we look at that, you can see that the image has been dimmed. All the bright stuff is toned down. But this particular line, which is the transfer function, so if you think of the input level is on the x-axis, the output level is on the y-axis. So every pixel here at about half scale will come out lower than half scale. But because it is linear, I can still do certain types of processing on that image. Now, I'll shut that down for a minute. There we are. In particular, deconvolution requires that the image not have had a nonlinear stretch. People tend to say you can't stretch it. That's not true. You can't stretch it non-linearly. The reason for that is it relies on using the stars in the image as the point spread function. And if you stretch it non-linearly, you change the shape of the star. That means that the deconvolution doesn't work accurately. It still works. You can still sharpen an image to some extent, but it's not as accurate as if you left the image unstretched or just linearly stretched. So when you hear people in PixInsight lingo talking about linear processing or a linear image, all they're talking about is the processing and the image before they apply a nonlinear stretch. Okay, everybody happy with that definition for now? I still have to move another window here. Bear with me. There we go. So we have two images here. And they look nice, but they have a nonlinear screen stretch applied to them. So if you look at this particular image, this is an image I shot maybe 4 or 5 days ago here at the cottage. And it's of the Elephant Trunk Nebula. It's a narrow band image. It was taken with an L extreme filter. And we're going to take a look at some of the stretching functions available in PixInsight as applied to this image, as well as this SHO palette image. I added in the next night after I took this, I added in the L Synergy filter. And it looks completely green here at the moment. We'll fix that here shortly, and I'll show you how. But first up, I'm going to just minimize this image. Actually, that's not what I'm going to do. I'm going to move it to another workspace, get it out of the way. There we go. So we're going to work initially on this closer to realistic image. It is still narrow band, so it's not an RGB image. But to give you an idea of some of the things that are available in PixInsight to stretch your images non-linearly. Now you can stretch them linearly as well, and several of the tools allow for that, and I'll show you that tonight. Once we take a quick look at some of the tools available, we're going to concentrate a little more on GHS. It is one of the best stretches I have come across for PixInsight. It gives you the most control that I have seen to date. It's not necessarily as easy to use as some of the others, so we'll spend a little more time on that. So first thing I'm going to do here, I'm going to turn off, well, actually, before I do, we will start with all the stretching is done here under intensity transformations. And there's a couple of these that I have not yet played with, at least not much. The arc sine stretch in PixInsight I find very limiting. It only gives you a couple of parameters to play with. And I'm used to the arc sine stretch in Images Plus, which has much greater flexibility. It turns out the GHS tool also has an arc sine stretch built in with all sorts of flexibility. So we'll look at that one. The first one I want to let everyone have a look at is one that most will probably be familiar with, which is the curves transformation. And the curves transformation is literally a mathematical curve that is applied to the image. It is the transfer function, meaning that the input values are along the x-axis. You multiply each input by the value of the curve to get the output. It's pretty straightforward. A typical stretch, now I'm going to turn off the screen stretch here to give you an idea. If we put a simple stretch here, we'll put a point here and we'll stretch the image up like so. And you can see you can barely see anything. It will take multiple passes, and I'm just going to duplicate this image so we can do it easily. It will take multiple passes to be able to stretch this enough to actually see anything. So if you take a look, after 4 passes of this particular curve, you can now start to see something in the image. The downside to this particular curve is anything past this level is saturated. It's just railed right along the top, and you can see that in the stars. They have gone white. Most of the star color has disappeared. We can modify that curve to prevent that from happening by adding another point and just pulling it over like so. So now what happens is even data at this end, its output level won't be clipped, but it'll be darn close. So again, if we pull up a real-time preview and we apply this curve a couple of times, one more, sorry. There we go. This star is definitely clipped, but if you zoom in on some of the other stars in the image, the smaller ones, you'll see they haven't clipped. So we can modify the curve all sorts of different ways. A typical curve that you would use for stretching an image is an S-curve. Bear with me. Duplicate that again. So an S-curve is pretty straightforward. You add a point and you shape the curve like the letter S. Oops, I have to add another point here. Bear with me. So you can see it's a very rough S shape here. And I could actually bring this down and make it more of an S, but that's the usual S curve right there. That tends to do a little better job than what we had, but because I've pulled down the dark areas here, and because the dark areas and because this image is almost completely dark, it will produce an image that really is not quite what you want. If we, 1 second, I'll just zoom out here. You'll notice that even after I apply it several times, I'm not seeing any great change because this area is actually darkened relative to what it used to be. So this curve is reserved mostly for an image that's already been stretched, just to bump up the contrast a little bit. So you can see the effect if we take an image and we stretch it first. And I'll just park a point there. And we'll make this curve a little more abrupt. And if we use this to stretch the image, okay, now you can see here's the image, but you notice it looks a little washed out. Now if I apply that S curve that we had just done, and I'll just apply a gentle one here, you'll be able to see the difference. You notice the contrast has climbed on that image compared to what it was. The lights got lighter and the darks got darker. And you can do a whole lot more of that. You know, you could bring, excuse me a second, you can bring the darker areas down even more, getting more and more, I'll open a real-time preview, getting more and more contrast in the image so you can see the difference here. We went from that to that with just an S-curve. And that's the best use for an S-curve, is increasing the contrast in your image after you have already stretched it. You can make them gentle or a little more severe like this one. Any questions so far? Okay. The tool, along with stretching the brightness of the image, I'm just going to up the contrast a little bit here. There we go. We'll do a couple of other things. You can stretch just the red channel. So if I wanted to boost the red levels sort of around, this brightness level, I can do that with this tool. And the way you do that is straightforward. You click on the red curve, and if I click here, can everyone see that vertical line on the curve? Is it showing up there, Jerry?
I didn't see where you clicked.
You see, 1 sec, I'll zoom in. I'm just clicking in this area.
I still don't see this area.
Oh, you can't see my cursor? Can you see
I
me?
don't notice it.
Can you see me moving my
Oh,
cursor?
yeah, right, there it is. Okay, yeah.
Okay, so I just clicked right here,
All right.
just above that faint star there. And can everyone see the line in the curves adjustment tool? There's a red vertical line.
Yep. And so
Yep.
Okay, that is the brightness level of the point where I clicked. So if I want to increase just that brightness level, I can add a point where that line was, add a couple of points above it, and a couple of points below it. What I'm attempting to do here is make a curve. Whoops, not like that. Sorry. Okay, so here was the area that we want to adjust. And you have to put a couple of points on either side. The reason for that is the curve tool. If I grab this point and I move it up, so now I'm brightening that area that we're looking at. We'll just zoom in on it here. Bear with me. So it's pretty subtle because I haven't, 1 second, I'll get a little ridiculous with it here. See if that shows up a little more. There we go. Everyone see that area on the
Oh, yeah.
real-time preview?
Yes.
Okay, so I'm now stretching just the red curve in that area. The reason you have to put a couple of points on either side, oops, I keep snagging it with my trackball as I go by, I apologize. If I get rid of this point, you notice the rest of the curve went down. The curves tool adjusts the whole curve to make it smooth. So thus I had to put another point here in order to not affect any of the stuff down here. So you need 2 points either side of the one you're adjusting. Now, if we bring this down to a more, normal boost, you can see the effect now as I click that on and off. I'm saturating the red in that area. It's pretty subtle, but can you see that? I don't know if it comes across on Zoom.
Yes, it does, but it's subtle.
It is very. As I said, I can make it less subtle. Now you can see what's happening, right?
Would
If
it
I-
be better to use
do
the
the
before and after
Yeah.
in the preview button itself rather than turning preview on and off?
Sorry, say that again, Jerry.
Wouldn't it be better to use the before and after button in the upper left of the preview
I
window
can.
rather than turning preview on and off?
I don't. One sec. I don't think it makes any difference here.
So that's before.
There's before. There's after. But it's
Yeah.
the same. It's exactly the same as just turning preview on and off.
Yeah.
Okay.
Now, one thing I can do, which might help. Nope, won't help. I've just turned on the 24-bit lookups for the screen stretch. But since I'm not using a screen stretch, that won't help. But what I'm trying to show here is that you can use the curves tool to subtly affect the color in areas of the image. So for instance, if we said, I want to take, I got to get a fainter area here, this faint area here. So if we reset this tool right here, and I want to turn the blue up in that area, not red. I just want to make it a little bluer right there. So again, you click on the image, you can see in the curves tool what brightness level that is, and you put a point there. And we'll pull that up a bit. We'll take that down, and we'll take that back down so that we're only affecting that small area. And then if I turn on the preview, now you'll notice that all of this area has gotten blue, but the bright area in here hasn't changed color much. See the effect? All the dim areas in the image have turned a slight shade bluer than they were. But the bright areas remain unchanged. So you can affect the color of your image with the curves tool, and you can use it for very fine adjustments of color, especially if you include masks to really make it fun. Another thing you can do with the curves tool, you do not have to stretch in RGB color space. You can stretch in lab space. So here's the luminance channel, the A and B channels. You can stretch in color saturation space. So you get the luminance, color, hue, and saturation. Color stretches can be really nice on stars because it will rev up the red in the stars quite nicely. So if we start here and sort of do a little bit of a curve here. Okay, can everyone see that effect? I'll turn it on and off. Watch the red in the image. See how it gets sort of super saturated? Is that coming across on Zoom?
Yeah. Yeah.
Okay, so again, you can slightly adjust colors with that color tool. You can change hues, which this one I always have a great deal of trouble with. What this says is green is here, and if I want to make green blue, I take this and I haul it up like that. So now what's happened is all the green has shifted toward the blue end of the spectrum. I never have had a good reason to use that yet. Again, it's really for making fine color adjustments more than anything. And finally, we've got saturation. So I can up the saturation of the whole image, as you can see. So you notice that this area is now much more saturated than it was. I'll turn it on and off. Again, with just a simple curve. But it's being applied to the saturation channel, so it's not being applied in RGB color space. Any questions there so far? Okay, its biggest use is, I find anyway, in fine-tuning an image after I have just about got it where I want it. I can turn up the saturation of the whole image, and I can change the color a bit. I can brighten it up in any given channel, or I can just increase the contrast of the image as a whole. Again, though, I usually use this tool on an image where I'm almost finished, and I'll generally use it with a mask. An example of what I mean with a mask, I'm going to make a very simple mask here to show you what I mean. We're going to make a mask that is, once it's finished here, just the luminance channel. And I'm going to put that on here. And I'll take the showing the mask off. There we are. So now when I stretch this image, the bright parts of the image are going to see the stretch. The dimmer parts down here will see less of a stretch, because that's the effect of the mask. Where the mask is bright, the effect of the curve is at a maximum. Where the mask is dark, the effect of the curve is at a minimum. And what we're going to do, we're going to use a curve to adjust this mask. First off, I'm going to increase the saturation a bit, or not saturation, rather the contrast of the mask. Now what I'm going to do, with that mask on this image, and if I do this, what I'm going to do is I'm going to boost the brightness of the image. I'm going way overboard here intentionally, so bear with me. You'll notice that the bright areas of the mask, right in around here, that's where the maximum brightening occurred. The dim areas of the mask, down here, it didn't brighten nearly as much. You notice that? So one technique that has been very useful in fine-tuning images is to pop a mask like this on, use it when I want to brighten up areas of the image. So here we want to brighten, let's say, right there. And just turn the contrast up a bit. And then what I want to do next, I want to darken. So I'm going to apply that to my image. Now what I want to do is I want to darken the dim areas, but not darken the bright areas as much. So what I'm going to do, I'm going to go back to the image, and I'm just going to invert the mask. By the way, this works for all stretches, not just curves. So now we'll invert the mask. And now if I take this curves adjustment and I lower the brightness in this area, you can see the effect, right? We got some decently enhanced contrast in this area. And I can do that a little more. There we go. Wherever now the mask is dark because I've inverted the mask, that's where this is going to be applied. So it darkens the dark areas and leaves the lighter areas alone. It's a technique that's actually fairly powerful when you're stretching images, especially when you want to just stretch, if I can zoom in here. If I had just wanted to stretch this bright area around here and leave all this dark area untouched, I can do that by making a mask that isolates that area. Make sense to everybody? Okay, now close this down, or I'll try to close it down. We don't need that mask anymore. Now there is another stretch tool here, which up until just recently was the go-to stretch tool in PixInsight. and it's the histogram transformation. It applies, Jerry, correct me if I'm wrong, an exponential stretch to the image.
I don't know.
I think it's an exponential. I'll look that up a little later just to make sure, but I think it's an exponential stretch. So the curve that you saw that we were using was a logarithmic curve. Exponential goes the other way. So it sort of starts off here and curves upward. And you have 3 sliders that are used to control this. So the first thing you have to do is, of course, select the image that you want to work on. So this point here, and I'm going to zoom in just a bit here. Bear with me, horizontally. Okay, so here's my histogram. You notice it's almost all black here, of course. And what I want to do, I want to brighten this up. So in order to brighten it up, I can do 2 things. I can brighten it up linearly by just grabbing this and pulling it back. Oh, I have to turn on real-time preview here, sorry. Right, so this is applying a linear stretch to that image. Oops, went too far. So there we go. However, again, all the stars are now saturated. So we don't really want to do that. That's where this second slider comes in. So now I can brighten up the bottom part of the image a little bit. And you notice that you can still make out here that this is not a single star, as opposed to the linear stretch that just made this completely wash out. And this was the go-to tool in PixInsight for doing the bulk of the stretching for quite a long time. And, for instance, I could now apply that stretch and then reset the tool. And now I can fine tune that stretch. So I can sort of, brighten it up a little more, dial in a little more contrast, and then brighten up the high end a bit. Oops, if I click on the tool, anyway, on the slider. So you can see what you get. You get almost independent control of the bright end of the picture, the dark end of the picture, and the midtones, right? And I can play around with various brightness levels to get this image where I want to start doing additional processing. So you can see here, now we've got an image that actually looks pretty good. One nice feature with this tool, if I undo the stretch that I did, is if you turn on a screen stretch. So here's a screen stretch done to the image. And I view the screen stretch. And where's the link tool? There we go. Nope, I want to link it there. And I can now drag this to the bottom of this guy. And it applies this stretch in here. They use the same exponential. Again, I think it's an exponential. They use the same exponential stretch, right? So I can apply this stretch. I did that wrong. Sorry. It is drag it to the bottom bar, isn't it, Jerry?
Yes, it is. Yes.
So I grab the triangle and I drag it to the bottom bar. Why isn't that setting? It should.
Don't forget to set the tracking, to track the
Yeah.
check mark.
Where is
Click
that?
on the check mark.
Check
Right
box.
there. Try that. Let's see what happens. It did stretch, but not, for some reason, it's not looking like I'm expecting here. Let me try one more time here. We'll reset it.
Reset your transfer function too.
Here we go. Now, turn on the screen stretch just for a minute. There we are. So now if I grab this and I put it up here, it's not doing what I'm expecting. Why not? What am I doing wrong here?
You haven't hit the nuclear button there yet, have you?
No, it should just apply the screen stretch that I've selected.
Select the track view in the screen transfer function. Maybe that.
Now
So
transfer.
track is on there. Track is on there.
Now
Let's
transfer.
try it.
There we go. That was what was wrong. So now if I turn on the preview, we get that image. So I can take a screen stretch as the initial start and just drag it onto the bottom bar of the histogram transformation. And in a lot of cases, it will give you a good start at stretching your image. I tend to find it a little aggressive. You'll notice what's happened here. This star is getting, you can't make out that this is actually 3 stars anymore. 2 of them have sort of blended together. And if you go to here, you can barely make out that this is a double. But that's a function of the settings in the screen stretch. So I could play around with that, the settings in the screen stretch, get what I wanted, then dump them into the histogram transformation and apply them directly to my image. So it's kind of a convenient tool in that sense. Up until GHS, this was also the only way you could see the histogram of your image in PixInsight. There is no dedicated histogram tool in PixInsight. You have to pull up the histogram transformation and zoom in a bit, and you can then see the histogram of your image. Okay. Let me close this down. There's a couple of other fairly useful transforms here, and some of them are I'm not going to cover them other than mention them tonight, simply because things like local histogram equalization, that's not really sort of a bulk stretching tool. You can use that to locally increase contrast in your image. But a mask stretch actually is fairly useful. You can set your targeted background level, how many iterations you're going to do. We'll let this go for 100. You can set the lower limit and the upper limit for your background, and then you can turn it loose on the image. You can also select a region of interest as well.
So how is it actually using the mask here?
And it'll crunch here for 100 iterations.
Blair, how is it actually using a mask here?
What's that?
How is it actually
So
using
what this is doing is it's actually
Blair, your audio once in a
making
while
a
breaks
mask
in and out.
of this. Assuming it finishes, maybe 100 iterations. Okay, just one sec. There we go. You hear me okay now?
Yeah.
Can everyone hear me okay? Okay. Yeah, the reason I was breaking up there is my computer was just simply too busy doing the PixInsight stuff. Okay, now you can see the result. It gave me an image. It's not quite as bright as I would like, and I could play around with the target background and so on to get that where I want, but it's bright enough now that I could apply a simple masked curve to it. And if you look, the double is clearly separated. And we've clearly got the 3 stars here, right? So what this has done is it's made a mask of the image, applied it to the image, stretched the image. Then it's made another mask, done the same thing. And at each iteration, it makes a new mask and applies it to the image. And it applies it in an inverted fashion, so it won't over brighten the stars, and it brings up the dark background. And you can apply it with however many iterations you want. It does crunch for a bit, as you saw. And the nice part about it is you get a wonderfully detailed image out of it. It's one of my go-to stretches for sort of finalizing things every now and then when I don't quite get what I want out of some of the other tools. You can do it manually with a curve or any of the other stretches and an inverted mask, but this tool just does it all with one click. It's really nice for doing that. Okay, back to intensity stretches. One that I didn't look at, although I'll quickly show you, is the color saturation tool. To me, I don't think of it as a nonlinear brightness transform, but a color transform. So I just turn on a screen stretch here. I can pick a color and then I can increase or decrease its saturation. So if I want to decrease the saturation in the red, you'll notice the red is at both sides of this. So the way to get around that is use this hue shift. You pop the red in the middle right here. Now what I'm going to do, I'm going to pull down the saturation in red. And I'll pull it down some more. All right, so now if I turn, you can see the difference. You notice how the red saturation has dropped right out? And right now I'm pulling down a little bit of the blue, so I can stop that by just putting another couple of points. And I'm pulling down a little bit of the yellow, so I can do the same thing. Right, so now I'm only affecting the red saturation. Tool is quite useful for tweaking and making final color adjustments to an image, especially in combination with a mask. But you can see the effect pretty straightforwardly there. Okay. Now we'll go back down here. And I'm going to pull up there's one more here. I haven't played a whole lot with the Multiscale Adaptive Stretch. It does a nice job in the tinkering that I've done. And the nice part about it is it's sort of a one click and forget it. Most of the time, the default values work just fine. So, we can just let this crunch for a second and you'll see the results in just a minute. You can play around with the sliders, but usually the default turns out, as you can see, pretty good. And the nice part about this, for PixInsight, you have these controls that allow you to control the saturation of the color, even though you've stretched the image. So if you're using a curve to stretch the image, you tend to lose color. Same thing happens here, but you have this color saturation boost. So here I'm boosting it by 50%, and this is a blend amount. And you can see the effect is really nice. It gives you a nice, colorful image. You've got good color in the stars. You've got reasonable separation in the stars. Even the double here is, easily separated. The downside is you get a little bit of pixelating. You notice through here, it's not quite as smooth as some of the other stretches. But if you're not going to pixel peep, that's a pretty good stretch to use to sort of have a one-click stretch and done. I'm getting a sign up coming up every now and then that says my internet connection is unstable. Can everyone still hear me okay? Okay.
Yeah, you're fine.
Okay, I'm at the end of an RF rural internet link, and the sun is going down, and it's now right in the beam width of the antenna. So my internet gets a little flaky this time of night. So at any rate, the Multiscale Adaptive Stretch is one that I would suggest people use as their new initial stretch when you're looking at native PixInsight tools. It used to be the Histogram Transformation, but now the Multiscale Adaptive Stretch does a really nice job very quickly, even with just the defaults. I didn't change anything in that slider. We'll now take a look at a stretch that is actually one of the best stretches I've come across. And it was, bear with me here, I have to move something out of the way. There we go. It was developed originally by, I think it's Dave Payne, if I remember correctly. Yeah, Dave Payne developed the math for it, and Mike Cranfield did the coding. And between the two of them, they came up with a really powerful, very easy to use, although you do have to get used to it, and quite flexible stretching system. Dave is an engineering type like myself out of the Vancouver Center, I think it is. I might be wrong on that, but I think it's the Vancouver Center. He developed the math behind the system, but Dave is not a programmer. So Dave got together with Mike, and Mike coded it up and provided some fantastic tools to make it easier to use. For anyone that wants to know the math behind it or anything, there's full documentation available for it as well. So the tool, as it's seen here, has several sort of, they're not tabs, I guess you call them tabs. One is the graphic tab, and in here you get a histogram of the image. You can zoom in, as you can see, up to 1,000 times. You can change the histogram from linear to log. You can plot the curve of the stretch or not. You can turn the grid on or off. I forget what this one does now. I think there's a mouse over. So this one will reject saturated pixels for the histogram. This one will show the pre-stretch histogram. So you can actually put them both up. You can see post-stretch and pre-stretch by turning them both on. And one of the nice functions about this particular stretch is that you can hang on to stars while stretching the image. So if, for example, we turn on a screen stretch just so we can see the image, and when I stretch this image, I want to put the maximum contrast at this brightness level right here. That point, if you can picture an S curve, the inflection point of that curve is where maximum contrast happens. In this case, it's called the symmetry point. And if I click here, you notice it drew a line right here. That is the symmetry point in my transfer function. If I click send to SP, it sends it down to the symmetry point value down here. Now, if I stretch this image, I'll turn the screen stretch off. Ooh, I better turn on the real-time preview or we won't see anything. So now we've got this point getting the maximum contrast in the stretch. It's not the brightest point, it's the point at which the contrast is maximum. So you can see that this really begins to pop out from the background gas and dust. Now, you notice we've saturated some areas, this star, for example. With the local intensity, we can fix that. If I turn that down, now my stars just came back. And I'll just zoom in so you can see. You see you got all 3 stars. I can make them a little more
He
obvious.
said, turn it
What's that?
down. The number went up, right? The value went up.
Yeah. Yeah. What I'm doing here by doing this, watch the shape of the red curve. You'll notice it gets steeper. You see that? Can you see it's getting steeper around the inflection point?
Yeah. Yeah.
Okay, so that's what local intensity controls, is the steepness of the curve through this area. And you can use that in your initial stretch to hang on to the stars and still brighten the image up, a lot. I'm going ridiculous amounts here, bear with me. There's another portion to this stretch that solves another problem. You'll notice that when I stretched this, you see how it's saturated here? Looks kind of ugly. If I stretch it in color mode rather than RGB mode, sorry, not saturation, color. Now I have another slider that's now available, which is this slider. And if I stretch this image, and if I can zoom in on an area here, bear with me. You notice how this is super saturated here. I can dial that down so that that doesn't happen. I can control how much color saturation is applied while I'm stretching, which is a really nice function. And you can do it visually. So it's not unlike the multiscale adaptive stretch, it's not a one click and done. You have to play around, and you usually make several passes at the processing. What I mean by that is I might make one pass where I'm going to stretch it in color mode. I'm going to take most of the image. So you see what I did? I clicked in the histogram, and I'm going to send that point down to the symmetry point. So this is my sky background level, right, where the histogram peaks. So what I've just done is now I'm going to stretch it with maximum contrast at the background level. And we'll brighten the image up a lot. We'll recover some of the stars. And we'll fix up, if we zoom in here, the oversaturation just by dialing it down. Right there. And one of the things that's nice about this is, you remember when we did the multiscale adaptive stretch, it got pixelated in this area. You notice that GHS still leaves everything nice and smooth through here with no pixelation, no increase in noise. It's one of the nice things about this stretch. We've actually managed to hang on to some star color as well. Typically, by the way, I use this after I take the stars out of the image. The double star is well defined, and probably even this one is still there as 3 stars. Now, that would be my initial crack at the image. So I tell it, okay, done. Then we'll reset the tool. And now we can go to work on this image. We can adjust things even more. So I would like to bring up the contrast in this area so that I can see this faint detail a little more. So again, you send it to the symmetry point. Now, as I brighten this up, oops, a little too much. Oh, I better show you one more thing about this tool that's actually quite nice. Down here, this fine adjustment. What this does is it gives me much finer control over whichever of these sliders I select. So right now it's set to the symmetry point. I'm going to set it to D, which is this scale factor that I was moving. If I set it to highest sensitivity, that's useful for linear images that haven't been stretched yet. Since this image has been stretched, okay, what's going on here? Okay, here we go. So now, by the way, it's cumulative. So if I keep sliding this up, you'll notice that this number keeps getting bigger, right? So if I slide it up, see how this keeps going? And same if you go the other way. But it gives you finer control over the stretch that you're applying, rather than grabbing this and finding that it's very, once you're in this area, it's very tricky to adjust. So you tend to get it close and then use this fine adjustment slider. And you can see now that I can sort of bring out, oops, a little too far. I can bring this up compared to the background quite nicely. Bear with me here. My email is doing something in the background. I'm just going to shut it down so it won't make any more noises. There we are. So now we have a shot that we've opened this up a bit. It's a little more detailed. We can check it now and make sure I haven't saturated anything I didn't want to. You notice that none of the coloring in here is saturated. We're still not pixelated in this area. And I've got some star, oops, on the button. And I've got some star color. You know, some of these stars are red. others are not. So now we've got a shot that avoids the problem of the multiscale adaptive stretch, pixelating the image a bit. It's close to the same stretch. It's not quite yet. And we can fix that by simply applying that stretch. Oops. And then doing that. Now what we're going to do, we're going to stretch the background a little bit. So I'm just going to sort of highlight this area. And I'm going to take this shade right here. You notice where it parked the symmetry point. And then we'll brighten up the background. So I'm going to send this in. And now the background brightens up, you notice. I don't want to saturate anything, so I can, wrong way. You have to play around a bit. Later while you're using this, you notice when we first started doing it, to recover things, I moved it this way. Now I actually have to go the other way. I have to reduce the slope of this line a bit. So now we'll turn this on and off. And you notice the contrast is coming up and the background is brightening up. But I haven't lost the detail in the bright areas. See that? And I can keep tweaking bit by bit to get the image pretty much exactly where I want. Because of the ability to change on each stretch where the maximum contrast is being applied, it's one of the reasons I really like this tool. So now, for instance, if we look here, look at the contrast we've pulled out on this feature, right? We can actually see some of the modeling and the tendrils of gas in here that we could not see when we first started. And we've done it without blowing out the rest of the image. That's something I find very difficult to do with any other stretch tool. It's one of the advantages of GHS is that you can work incrementally and you can select the area where you're going to apply maximum contrast boost. That doesn't mean that you can say, I only want to boost this area over here. If you wanted to do that, you'd have to apply a mask. It would take this brightness, and anywhere where that brightness exists in the image, it would apply that
this
same.
meeting is being recorded.
Oops. So at any rate, you can see you can work bit by bit to get the image pretty much exactly where you want it. And if we zoom in here, oops, it's over zoomed. So we zoom in here, you can see there's a fair amount of detail. The contrast is getting a little high, and I can fix that with this tool. It has I said contrast, I meant saturation, sorry. It has a saturation tool. This would boost I better reset it, sorry. This would boost the saturation. I want to turn down the saturation for the bright areas just a little bit. What I do is I just click invert. And now when I dial this up, oops, I'm dialing down the saturation. You notice that in here, right? So you can see I've turned the saturation down. And what I would tend to do to fix that is just move this ever so slightly and then do the rest of the work with this tool, or with this slider rather. So now if you take a look, we've got reasonable saturation control in here. I may have turned it down a little too much. There we go. You get the idea. And you can play with this. You can adjust the saturation at any given saturation level. So if I wanted to boost this saturation level here, I can do that. I would simply select, I got to zoom in again, sorry. I want to boost the saturation for this color. That's this point. Send it to the Symmetry tool. Clear that, and then boost the saturation, right? Because that is so dim in that area, oops, there we go. Because that's so dim in that area, there we are. So you can see I'm boosting that saturation a maximum amount, which is way too much for the image. You can imagine what that's done to the rest of the image, right? But I have control where I can start bringing up the saturation in this area, and I can actually adjust that. I probably want to go the other way. There we are. I can protect the highlights a bit better. Oh, that doesn't work for saturation, sorry. So now you can see what we've done. We've boosted the saturation, but the maximum saturation boost is in this area. So if hopefully that's coming across on Zoom. When I look at this, this becomes quite red, and now it's almost gray. Can you see that difference? There it is, unsaturated or unboosted. I'll dial it up a little more so it becomes a little more obvious. 1 second. Okay, look in this area where I selected a big saturation boost. Can you see the difference there now? Right, and I can now do that in any area. I will increase the saturation in other areas. There's no doubt about that. And you can notice that here, right? But I haven't done what's called saturation clipping. It's not overly saturated, and I can then dial this back down using an inverse curve on the saturation. There. And if you look at that image now, we've got some red through. I overdid it a little bit, but we've got red through here, and I lost a lot of the red through here. I unfortunately overdid that. Let me dial that back. There we are. So if you look here, this is close to clipping, but not quite. If I apply this to the image, now it's much better through here, and I still have color in this area. So the same sort of technique that you would use for changing the brightness in the image also works for the saturation. Again, you can do any individual channel. Now, there's one thing I'll show you here that is very handy with this tool. If you go and look at all 3 channels here, you'll notice the histograms are not lined up. Okay, ideally, if you are having an image, you'd like to have the red, the green, and the blue peak all at the same level. It gives you a black background, or a dark gray, I should say. There's a linear stretch that you have here that will let me move those around. So if you look now, I'm just going to adjust the red histogram and turn it up a bit. There. Now these areas are black, dark gray, as opposed to what they were, which was a little greenish blue. Oops. You see the difference? So you can use that coupled with the generalized hyperbolic stretch to change or shift the color of regions of the image. So if you look at this filter is predominantly hydrogen alpha. It's predominantly red. But you notice there is some O3 in this area right here. And it would be nice to bring that up a bit. And you can do that with this tool. You can stretch just the blue channel. And typically what you do is you stretch it from the background up. You don't have to. You can, select here, for example. I'm going to send that down. Now, what we're going to do is we're going to stretch it ever so slightly, like so. And I've only stretched the blue channel. I haven't stretched the red channel. Now, we're going to go back to that linear stretch and realign the histogram. So we're going to affect just the blue channel. And we're going to, realign it with the other, histograms. Now look at what we've got. We've got a nice red image here, and look at all the blue that came up in this area. Right? So you can pull out faint O3 emissions that were in your image just by applying the stretch to one color channel and then lining the histograms back up. Let me just click done here. So now we have an image that's got all sorts of blue in it. To my eye, a little too much blue in it because I probably overstretched it. But you get the idea. I can bring out colors in an image that would not otherwise be easily visible. And I'm going to go to the other image that I had up originally here. I don't have to close that, sorry. I'll go over here. Here is an SHO shot of the same target. And you will notice that it is overwhelmed by the green, by the hydrogen alpha emission. If we, okay, that's a screen stretch. So if we use GHS to stretch this image, and we sort of, you see right away the HA is really high compared to the other histograms. So what we're going to do, we're just going to stretch it in color mode first, which is what I generally do. Oops, not saturation, color. And we'll set the histogram to sort of the average background level. That's where I'm going to apply maximum contrast. Something disappeared on me there. There we are. So send that down to the symmetry point. Now I'm going to stretch this image. I'll take off the screen stretch. Oh, and turn on the real-time preview. I'm not going to worry too much about the blown out stars here at the moment. I'll just fix them up a little bit because I want to show you how to recover the color that you would normally have in this image. Okay, so there we've stretched the image. Oops. But it's predominantly green. So what we want to do is we want to take this green histogram, invert the GHS stretch. So now we're going to dim that channel rather than brighten it. We're going to slide it down. Line it up with the other channels. Right away, you start to see some of the other colors popping out. Okay, we'll start with that. Then the next thing we're going to do is now I'm going to take the red channel and I'm going to stretch it just like we did before. And again, selecting the background, sending it to the symmetry point, and then we can increase the red in the image. I should have taken the stars out because the stars are screwing up the histogram. But you get the idea here. Let's just stretch that a little. And then we're going to line that histogram up again. So we're just going to reset the stretch, pick the red channel, go to linear. And you'll notice now we're starting to get some red in here. You'll notice the stars are getting really wonky. And normally what I would do is I would have taken the stars out of this image to avoid that. But you can see after a couple of iterations of doing that, I will get an image that looks the way I want. And just to give you an idea of what you get after you do that several times, I'm just going to open an image here. Zoom. Now I have to find it. Bear with me. There it is. So you can see this is the same image. All I've done when I processed this, I took the stars out, and then I played, just as I had done there with the color, to get the red out in this image. Now we've got a decent looking SHO palette image, all done with one tool, the GHS stretch. And it took it from that flat green all the way to lots of different colors in the image using that technique of stretching a single color channel a little bit and then bringing the histogram peak to line up with all the others. It took about 4 iterations to get all this nice red out in the image and about another iteration to get this blue out around here. Any questions on using GHS so far?
Well, after spending a lot of time trying to do that and never succeeding, I'm gone.
I'll give you an idea if you, 1 second here. If we do this stretch the right way, which is to get rid of the stars first, so bear with me. I'm going to do one other thing. This is the screen stretch for this image, by the way. I'm going to do one other thing just to save time. I'm going to shrink the image by 2. Integer resample. There we go, by 2. It will make the AI tools much faster. If we take the stars out of this image, watch the difference. The stars don't destroy the histogram display once they're out, so it makes things much easier to sort out. Remember, this is still a linear image at this point. It's just a screen stretch that's making it visible. I was talking to Russ, by the way, at RC Astro, for those that are interested. For those of us that do not have NVIDIA video cards, he's working on a version of the PixInsight plugins that will run on a variety of different graphics cards, including Intel. So for those of us that have Intel graphics, we'll finally get GPU acceleration on all these nice AI functions. That's coming in the near future. So here's the image again. 1 second, I have to turn off the screen stretch. Oh, by the way, before I do that, there we are. So all I've done there is I've now equalized the screen stretch on each of the color channels, so you can see that it is the same green image that it always was there. And we'll go to GHS, reset the display, zoom in so I can see the histogram, go to color mode, set the symmetry point, and then what we're going to do is take off the screen stretch, and we'll do our initial stretch. Oops, I grab the slider. And I'm just going to slide the symmetry point a little higher just to up the contrast in some of the areas there. There we go. And right now, we're a little color saturated in through here, as you can see. And you fix that with the color blend amount. And you just dial it down until you're no longer color saturated, about there. And then we look, here's the simple lump stretch on that image, if you will. And now we're going to go to work on the color. So now what we'll do is we'll look here. We have a choice. We can stretch the reds up, or we can bring the green down, and we'll do both. So we will work on the green channel, invert it. Again, take the sort of background green level there, send it to the symmetry point. And then what we're going to do, we're just going to dial this like so. Why didn't that move? Oh, sorry. I have to, bear with me a second. I have to set the symmetry point down here. Then we should compress the green. There we go. So now you can see what's happening. Can everyone notice the faint blue that's showing up here? It's pretty subtle, but can you see it there?
Yeah.
Okay, so if you look, before I compressed the green, there's no sign of it. Now we start to see the faint O3 emission in that area. Okay, now what we're going to do, we're going to take red and bring it up to the green peak. So did I apply that to the image yet? No, I didn't. Okay, one sec. There we go. So now what we're going to do is take the red and increase it. Red, generalized hyperbolic stretch for red. We'll click on the peak for the symmetry point, and I'll increase red. Just a little bit. We don't want to go too much here. Okay, and then we're going to line that histogram peak back up with the blue histogram peak. So first we have to apply that. Then we'll go to linear stretch. Again, just on the red channel. And we're going to line the red histogram peak. If I can click on that, there we go. Now, you notice what has happened. One sec. I'm just fine-tuning that to line the histogram peaks up. There we go. So that's one iteration of that technique. And you can notice, if you look at the image, that we're starting to bring red out in this bottom portion. We'll repeat that a couple of times. And we can do this because the stars aren't in there. The stars screwed us up the last time. So now we're going to stretch the red a little bit more. Same technique, select the peak as the symmetry point, and we will just a little bit, don't want to go too far. If you don't go far enough, then another iteration will help. If you go too far, it screws it up, and you have to backtrack a bit. So if we go to there, for example, and then go to a linear stretch on just the red channel. And now we're going to slide this peak back down to the blue. Now you notice the red is getting more and more prominent. Done. And if you look at it now, compared to what it used to be just completely green. Now, the image is green, but you've got red and you've got some blue in this area. Everybody see that? And we can dial the green down just a little bit more. Again. Now, the nice part about using this inverted curve, it will compress the data against wherever I put the symmetry point. So I'm going to put the symmetry point right there. And you'll notice what happens if I do this, it's compressing green and it's not sliding it down very far. So I've taken a little too much green out there, but you get the idea, right? If I turn that off, turn it back on, I can play a bit with the amount. Ooh, too much. Right, that's a little too much, I think. Right about there. So now we can dial up the blue a little bit. You can keep going until you get the color you want. Once you have the color you want, you can put the stars back in. So now we've got an image that's getting pretty close to what we would probably want out of this. The catch now is we want to up the image contrast a bit. So what we'll do is we'll sort of say, I want to stretch it and put maximum contrast about there. By the way, you can select this symmetry point three ways. You can move the slider or type in here. You can click on the graph, or you can click on any point in the image. Obviously, clicking on the image is a little bit better than trying to pick the brightness out of here. So now that we're there, we can sort of brighten this up a little bit. Maybe just a little bit more. Now you're getting a pretty good image. There we go. So now if we take a look, we have a nice SHO image. We don't have the pixelation that we were getting from the multiscale adaptive stretch in this area. And look at the detail as you go down through there. Is that coming across reasonably well on Zoom? Right? And of course, now all we have to do is put the stars back in. But you can't just put the stars in because they haven't been stretched yet. So we have to stretch the stars. Again, using GHS. Normally, I would do it in color mode, but I wouldn't be putting stars from an SHO palette back in. I'd put stars from the HOO image, if you will, this image, because I like the stars in this one. The color of the stars much better. But for now, we'll just put the stars from the SHO data back in. So what we're going to do here, we'll turn off the screen stretch. We'll stretch RGB stretch and just, oops, I have to do this. And we'll just dial up the stars to some reasonable brightness. Maybe around there. And let's just make sure that we've still got, yeah, the double is still visible. This may not be bright enough, but we'll soon see, because we can do multiple iterations of this if necessary. I'm just going to call this S to make life easy. And we will use pixel math to put the stars back in. And you can use your favorite combine expression. This one generally works. It's just a screen combine. I shouldn't have typed a capital there, sorry. If I could type, it'd be dangerous. There we go. So what we're going to do now, we will create a new image with the stars back in. There we go. So now we've got stars back in. They haven't saturated, so we can clearly see there's a double there. We can clearly, well, almost clearly see the 3 stars there. And there we have a first pass at an SHO image. Did that sort of answer your question, Bob, on how you get those colors back?
Yeah. Now I just have to get the SHO image.
That I can't help you with. And again, if you want the stars to be a little brighter, there's a neat trick you can do for that. You make a mask out of the luminance channel of the stars. You put it on this image. And I'll hide the mask here. And all I'm going to do, I'm going to add some fraction of the stars back into this image again. So what will happen here, I will say $T, which is this image, plus, and we'll pick a number, 0.1 times S. And we'll just replace that over this image. Let's see what happens. So now the stars got a little bit brighter, maybe not bright enough. You might like them even brighter. So we can make this 0.1, 0.5 as an example. Everyone see those stars get slightly brighter there? I'll undo it so you can see it. And I'll zoom in, make it a little easier. Not past 100%. There we go. Everyone see the bright stars get just a little bit brighter? Look down here. And you can, you can play with that percentage. So rather than 50% of the stars added in, let's add 70% of the stars back in. Now they'll get even brighter still. They would get really brighter if I did it to the right image. There we go. There. So now if we zoom out, I'll undo that so you can see the difference and then redo it. Everyone see the stars get just a little bit brighter? Especially, for instance, over here. If you watch there, see the difference? Is that coming across in zoom? I'll zoom in a bit, pardon the pun. There, it's a little more obvious there, right? So what that's doing is making the stars a little bit brighter. We've still got some separation of the double stars there. And there we have an SHO palette image without the foolish purple stars that drive me nuts every time I look at SHO images. And I could even pull in red stars from the other filter. So if we had looked and I had taken the stars from this image out, we could put those in, and rather than putting the SHO stars in. That's what I did for the shot that is now hidden. Bear with me. Where'd it go? That is what I did for this shot. I pulled in stars from just the L Extreme filter, so effectively they're HOO stars, and put them in the Hubble palette shot. And it makes for at least to my way of thinking, a nicer image than having big, bright purple stars. I don't tend to like those in the Hubble palette. Hopefully that gives you an idea of what you can do with some of the stretch tools, in particular generalized hyperbolic stretch. Now, one thing I have not done to this image at all, we haven't done any sharpening or local contrast enhancement. All that has been done to this version, of course. But just to give you an idea, if we take that mask off, and we use the tool that I said I would mention. Whoops, wrong tool. Too easy to bump the button on this trackball. We're going to go to local histogram equalization. And what this does is it will up the contrast in small regions of the image. You get to determine the region. So the kernel this is going to use here is a 64 pixel radius. You can play with that to get the result you want. And you also have to play with the amount slider. You notice it did really made it yucky. So simple thing is you just turn down the amount. There we go. Now it's getting better. So now if we look at it, everyone see the difference in this area right here? If I reapply it and take it off, and we can make it affect different scales in the image. There we go. That's not too bad. So if we turn this up a bit, that's pretty good. So now watch what happens. I'll turn it off. I'll turn it back on. Everybody see the difference? Right? So it increased the contrast locally in the image. So if we apply that, it does take a second to actually run. Okay, now I'll get rid of this. We'll go back to here and we'll turn it on. We'll undo it. Oh, you know what? I applied it to the wrong image. Sorry. Let's apply it to this guy this time. There we are. So now if I undo that and I redo it, you see the difference? Do it again. Undo, redo. Okay, one other thing you can do, generally I would apply local histogram equalization not to the image with the stars in it. The reason being, I like to get rid of the stars here if I go back far enough. Ooh, that's not good. That is image 10. No, that was the pixel math. Hopefully I didn't shut down the image that had, yeah, it looks like I did. Nope. Image 8. Undo the star combine. There we are. So if we take that and I apply this adjustment to this image before I put the stars in, then local histogram equalization won't saturate the stars on me. So you can see same effect, and I can carry it further now because what I can do, I can make a mask and apply the mask to the image. I'll just turn off the display of the mask, and then we can really crank this, and the mask will help us out quite a bit. So you see what's happening now? The mask protects areas of the darker areas of the image so we don't bring up a lot of noise. But look at what it does for you in, for instance, this area. See how the contrast comes way up? So we can now apply that. So now we have an image that looks like this. You're starting to see all sorts of detail in the dust here. And then finally we can sharpen it a little bit. Use your favorite sharpening tool. I know we haven't gotten into a lot of them yet, but if we do an Unsharp Mask, for example, and again, you have to sort of zoom in on this. If we sort of look at this area, and we'll say, that's actually not too bad, just like that. Everyone see the improvement in image sharpness there? There's the sharpened image. There it is unsharpened. It's subtle, but definitely there. Okay, so we'll apply that to the image. The nice part about it is I'm applying it with that mask that's on there, so it's only being applied to the bright areas of the image. Look at the detail it brought out. All right. Now we can add the stars back in. Where's $sign? And we'll make a new image so we don't overwrite any of our other two images. And then finally, we can brighten those stars up a bit by just adding in some fraction of stars again. I think we use 0.7 if I remember correctly. And we'll add that with a star mask. Now I got to find the star mask. Where to hide that? There it is, I think. Yep. We put the star mask back over this. So this way we're adding the stars in, but we're not adding the black from the star image, just the bright stars. And we'll do that. That brighten them up a bit. So now if you look at this, look at the detail, if I go back to 1-to-1 here, that this has put in the image. look at, wrong way. Look at what you get down in, this area of gas and dust. And that's all due to using GHS to pull all that out and preserve as much of the dynamic range as you can, and then simply sharpening with a mask on the image before you add the stars back in. And you end up with a pretty good image. Now we get up of course, remember how I said I use curves for sort of the final adjustments here. Let me remove the mask. And we can up the saturation to taste sort of thing using a curve. Oop, wrong one. So if we look at the curve transform, and we're going to increase the saturation now. And you have to be careful with this because it's really easy to go too far very quickly. Everybody see that difference? And I could set that up so I don't boost the green quite so much, but we'll leave it at that for now. Yep. So there we have it. We now have an SHO palette image produced from that image that was sort of monochrome green. And all we did was stretch the color channels individually using GHS after we stretched the whole image. And it's one of the few tools other than curves that allows you to do that individually to the color channels and see the results on the histogram right away so you know if you've done something wrong. In this particular case, I would have boosted the red a little more, but this is just something quick so we can show people. Any questions?
If you were starting with strictly an RGB image with your one-shot color,
Yep.
how would you break out the channels and then recombine them?
I never break out the channels. I may operate on them individually. You notice at no point here did we break the channels out into 3 images. We just operated on individual channels. So to give you an idea, somewhere here, Bob, just bear with me a second. I'll close down a few images here. Here's a question for those that have used PixInsight for a while. Is there a close all open images function?
Lower left hand, I think.
Lower left?
Yeah, if memory serves, there is a close.
Sorry, Bob, you broke up there.
I think the short answer is yes. I'm using my space bar so I don't have to go and find the button to turn me back on again. And I'm clicking on your file, and I.
Okay, I'm going to open an RGB image just to show you what I mean. Now I got to find it. Surely to God, I've got an RGB image in here. Flying Dragon. Okay, here's Flying Dragon. This is an image of the Flying Dragon that was taken using an L-enhance filter. So it's not strictly RGB, but pretty close to it. That filter has fairly broad passbands. So if we wanted to take this, again, I'm going to just, for the sake of expediency here, I'm going to shrink the image by 2, just so that the AI stuff will run much quicker. There we go. So you can see right away the problem with the screen stretch. The stars are big and bright and the nebula is not very visible. So very first thing we would do is remove the stars so we can operate on just the nebula. This just takes a second. How are we doing on time here? Yeah, we're okay. This, by the way, Bob, is my discovery image, if you will, of the dragon's ring.
Yeah, I remember that one.
Yeah. Just it's about halfway through here, removing the stars. Oh, excuse me. Okay, now let's use 24-bit. And what we're going to do, we're going to try and bring out the dragon from the background using GHS. So again, GHS, reset it, and we'll zoom in to see the histogram. And again, I do my first stretch in color mode to maintain as much color as I can. And I usually place the symmetry point at the peak of the histogram. That way I am getting maximum contrast in the background, if you will. So you send that in, and now what we'll do is we will stretch it. And we'll get rid of the oversaturation. I'm just going to zoom in to have a look to make sure that I didn't oversaturate things. That looks pretty good. So there's our sort of first initial stretch on the image. And now we can play with the symmetry point just to see what we can do with contrast here. Maybe about there. Okay, we'll apply that. Come on, apply. There we go. And I think, no, not that one, this one. There we go. So now you can begin to see the image. And one of the things that's popping out, Bob, you'll notice it right away, is the OIII ring that's in this. And this was the image that I managed to sort of discover this in. Most other images you see, they've stretched this to the point where this is all red. But there's actually this faint OIII ring. You notice the bluish green emission there. And we've looking into what actually causes that. It's probably a reflection from stars, but we can't figure out what stars. We think it's actually stars behind all this gas and dust that you can't see. But you can see, Bob, this is an RGB image, and now we can start working on bringing out more detail in various points of this image. So again, what we'll want to do is now we want to make the bright parts of the image a little bit brighter. So what we'll do, we'll click, oops, I have to reset this, bear with me. There we go. We'll click here to set the symmetry point to that brightness level. So you can see there it is there. And now when we stretch this, it's going to dim the black background. There we go. And I want to protect the shadows just a little bit. There are two sliders I didn't show you before, but what I'm going to overstretch this so you can see what they do here. Just bear with me a minute. Okay, you notice that this has gone maybe a little too far to the black. It's starting to get close to clipping. And you can see this part of the curve here. We can control the slope of that part of the curve. So everything below the symmetry point with this protect shadows slider. I can protect the highlights and keep them from clipping, doing the same thing to this upper part of the curve with the protect highlights slider. And you can see what's happening here now. I can get some decent control. You know, I can make the background really bright, which I don't want to do. I can let it get somewhat darker, which I do want to do. So you can see now the background is sort of staying roughly where it is, and the nebula is starting to pop right out. Everybody see that? So let's try applying that. The saturation boost is a little more than I would like, so we'll turn down the saturation just a little bit by using invert. And we're just going to take it down a little bit, right about there. And apply that. And then we can boost it a little bit more. Again, you do it in small increments. You can do it all at once if you want, but it's very difficult to get good control on things like this gas cloud in this area if you try and boost everything all at once. So now we're going to take this and I'm going to brighten this gas cloud up a little bit. So we'll send that in as the symmetry point. Now you start to see that gas cloud in there. There we are. Can everyone see that gas start to pop out? The real faint stuff? There we are. And now that's a reasonable start without any sharpening or anything like that. So you can see here's the dragon. You can see all of the dim gas that's surrounding it. I haven't done anything to bring the noise down yet. It does a pretty good job of stretching without killing the noise floor. Now we just have to put the stars back in. So again, we're going to stretch the stars in color mode to keep color in the stars. It would help if I turn on the real-time preview. That's probably pretty good. Now, one thing I want to show you that you have to watch out for. If you take a look, if I reset this slider, you notice this star has a blue halo. If I bring the local intensity up too far, now I get a star that's almost all halo, and it doesn't look natural. It looks kind of fuzzy. There's a way of avoiding that, and we'll cover that in future sessions. But generally, just a cautionary note of you don't want to slide this too far to the right when you're stretching the star layer. A little bit brings in a little more star color. Too much makes these stars mostly halo and they kind of look yucky. But that's not too bad there. We'll dim the stars just a little bit. There we go. And then we'll add that in and see what it looks like. So we'll close that. Here's my stars. We'll call this layer S. I could leave it as it is, but I just hate typing that much, so we'll call it S. And we'll use pixel math to put them back in. There are a variety of different pixel math expressions that will put the stars back in. The one I'm using, a screen combine, the reason I use it is that it prevents saturation of the stars. You won't blow the stars out by using this one. It's just complaining about S. Didn't I call that S? No, I didn't. Look at that. I forgot. Identifier, S. I must have clicked cancel instead of save. And there we go. Nope. I have to click on this. Okay, now we've got our image. We could now go to work and finish up this image. So I could sharpen it. I could use local histogram equalization, which I would do on this image before putting the stars in. So again, local histogram equalization. Play with it a bit to get the best sort of That's not too bad there. Maybe a little too much, but we'll go with that. So let's see what that does. You can see the difference. You get a little more contrast in the image there. So we'll apply that. Then what we'll do is we will make a mask so that we don't affect the dimmer areas of the image as much. There. So now what we're going to do, we're going to sharpen this. And again, rather than, there's a tool that I like to use, which is the multiscale processing linear transform or median transform. But for tonight, because it's much quicker, we will just use an Unsharp Mask. And if we zoom in on this and sort of look in this area, everybody see the difference? And it's a little too much. It's bringing the noise up a bit. So we'll just dial the level down. See what that does. That's pretty subtle, but it is sharpening that. Now, I don't know if that's showing up in Zoom. I will sharpen it a little bit more so that it does show up, just so you can see it. Can you see that difference? Iffy. I can do it so you definitely see a difference. The only problem is that it will simply make a ball of noise here. 1 second. See if I can make this work. Can you see that difference? Okay. Trust me.
It's not coming through. It's not coming through as well.
Yeah, I didn't think it would with Zoom. Zoom will tend to compress some data. So trust me, it got sharper. Now, the next thing we're going to want to do with this is maybe up the contrast a little bit. And that's a simple one to use. Okay, we're going to do something here. I'm going to take this and I'm going to stretch it using a curve. Just going to make the bright stuff brighter and the dark stuff a little darker. There we are. So now what I'm doing here, this mask right now is applied to this image. So what's going to happen, I'm going to use this curve. Remember, we talked about this technique earlier. And I'm going to brighten the bright areas. Oops, I'm not on the mask on this image. So everyone see how the bright areas got brighter? Okay. Now what we're going to do, after doing that, I'm going to invert the mask and dim down the dark areas. So you can see the difference.
I didn't notice, but you had applied the first transformation before you did the inversion.
1 sec. Okay, so there's the sharpen. Now, here's where I brighten up the bright areas. Do you see that, Jerry?
Yeah.
Okay, and then we darken the dark areas.
Okay, good.
Got it?
But in terms of curve transformation, you did apply it.
Oh, you didn't see the curve.
I didn't see you hit apply.
Oh, I did.
Yeah. Okay. Thanks.
So now we have an image that's just about there. Right, now we can add those stars back in.
Blair, before you do that,
Yep.
if you wanted to increase the saturation of the O3 at this point.
At this point. Okay, let's do that. So let's get rid of the mask. You could use curves. I don't tend to like the result too much, so I'm going to go back to GHS. And what we're going to do, here's my histogram. We're going to affect the blue channel, and we might want to do a little bit of the green too, but we'll see. So I want to take the blue at about here. So you can see the line is shown up there. I'll send that to the symmetry point. And now what we're going to do is ever so slightly, well, I better turn on the real-time preview. Okay, so take a look. You see how the blue has sort of highlighted a bit?
Yeah, it's starting to come out now a little bit.
Yeah. So then we'll just take this up a little bit more. That's probably about enough there. Click apply. Now we have to line the histogram back up so our background is not blue anymore. And you do that with a linear adjustment to the blue channel. And we're going to take the blue and line it up with the green. Don't think I've gone far enough there. One sec. That's not doing, I might have stretched it a little too much, Bob. You notice the background here has a lot of blue in it?
Yeah, I can see that.
Yeah, but that's O3 emission that's in that area.
Mhm.
But I
The
think I
real-time
overstretched
preview,
it
isn't
just a little bit. So if we just pop back a bit,
Aren't you looking at the real-time preview there, which isn't enabled?
it was.
Yeah.
So if we get here, make sure I'm back to where I think I am. View history. I should be. What is this called? No filter. So there. So there's no GHS stretch done now. And what we're going to do is we're going to stretch the blue, just not as much as I did, Bob.
Gotcha.
Well, obviously, there's a little trial and error in this.
Oh, yeah.
There we go. So now we're going to move the blue slider up just a bit. And what I'm doing is I'm turning on this fine adjustment to make it a little easier to get what I want.
Roll.
Okay, and turn that on. A little too
Okay.
far. Okay, so maybe about there. And now bring that back. There, see if that will do what we want. So apply that. Now we'll go to the linear portion. Turn on just the blue channel. Since it's going linear, it really doesn't matter. There we go. And what we're going to do now is take the blue channel down and line it up with the, there, that's not bad. So now you can see it. You see the ring starting to pop out a bit?
Yep.
And
Yes, I
you're
can.
still getting some O3 emission in here, but it's not overpowering the background anymore. Okay, so basically that's how you do that. Now we've got the ring showing up here. And we can now combine that with the stars. And then as a final adjustment, we want to set the black point because the black point is quite high in this image, as you notice. And I'll show you another trick using GHS here. But normally people set that with a linear adjustment. So they'll dial the black point up like, or down, I should say, like that. And then they can, if they want, they can brighten the image up a bit with the white point. Oop, going the wrong way, sorry. Right, and get what you want. The problem with that is that this, if you move the black point too high, you can accidentally clip the image. So now I'm clipping some of the black. And that's because the black point is here, and you can see where it is in the resulting histogram. You're losing all this stuff out here. One way to avoid that with GHS is set the symmetry point close to the tail. So somewhere around here. And then send it to the symmetry point and take the protect highlights and pull it down until it meets the symmetry point. It won't go any further. Now when you try and stretch it, it's going to move the whole curve down, but it won't go any further than that. It will stop, and you're no longer clipping the background. All right, so I can now set that like so, and now we've got an image that shows the ring that we talked about earlier. The stars are nice and small, colorful, and you've got the nebula there. I'll just dump that out. Right, and you can set the black point wherever you want in the image. You could even pull up a linear adjustment to lower the black point still more if you want. You have to be careful, though, not to clip the image. There's not bad. So there we go. There is the Flying Dragon Nebula. And what I've been calling the Dragon's Ring. Think of it as a smoke ring from the dragon. And we think this is being illuminated from the background. Now, it could be the foreground from this. So if you picture this HA emission cloud is coming across in front of this, behind this cloud is a star cluster that we can't see, and it's illuminating this ring of material here. Too far. There we go. So there you have it. That's the same technique Bob used on an RGB image to pull out the O3 data that's in that image using GHS and just small steps in the stretch of the blue channel.
So that's what I mentioned earlier, and I've been trying to do something like that and didn't know the technique, so it ended up always in a mess.
Yeah, the catch is very slight stretch using GHS mode, and then go to linear mode and line the histogram peaks up again.
Yeah, and that's what I wasn't doing.
Yeah, and then after that, if it's still not bright enough, repeat.
Yeah. Press the destruct button and start again.
Yeah, you have to line the histogram peaks up. Otherwise, all this black stuff here will turn blue on you.
Yep, it sure did.
Yeah. Okay.
That's great, Blair. Thank you.
I think that pretty much finishes up our stretching session on, I admittedly predominantly covered GHS because it is so flexible. It is well worth learning to use the tool. I'm going to start telling Dave I want royalties. It's one of the best stretch tools for flexibility and capability that I've found, but it is not a one-button stretch like the Multiscale Adaptive Stretch. It definitely takes a bit of getting used to, and it takes several stretches to get the image where you want, but the flexibility is just incredible. And it's free, which is even better. Any other questions?
Oh, that's super, Blair. Thank you.
Okay. At that point, we'll call it a night, and Jerry will get the video up when he gets some time, and it'll be on the website that people can download it and review it at their leisure.
Will do.
Yep.
Thank you, Blair.
Thank you, Blair.
You're welcome.
Thanks, Blair. Thank you.
Yep. What we'll do next time is, let's see, look at sharpening, especially using some of the multi-scale techniques that are available in PixInsight. They did a nice job with their multi-scale tools, and we'll look at them for sharpening images. They do a nice job. Okay, good night, everybody.
Thank you.